Okay, we're going to look at 8.1, Introduction to Functions. So we're going to talk about what is a function, and then we're going to graph different types of functions. So before we talk about a function, let's talk about a relation. And a relation is a relationship between sets of information. For example, how many gallons of gas you get, and then what your cost is going to be for that. That's a relationship between number of gallons and your total bill. A function is a relation in which no ordered pairs have the same first coordinates. It is a rule that takes some input, so in the example above we were talking about gallons of gas, does something to it. For the gas it would multiply by the cost per gallon and gives a corresponding output, or whatever our bill would then be, depending on how many gallons we buy. So how do we write a function? We write an equation with function notation because it delineates to everyone that this is a function. So a function can be described using function notation. So if the name of the function is f and the input is x, so you're inputting x, we'll let x stand for the number of gallons of gas, then the output is called f of x. It's read as f of x, that's not multiplication, it's of. So this is a function f, and your input is x. And when you see f of x, you can think y. So when you graphed linear equations, you might graph something like y equals 3x plus 2. Well, you can also write that as f of x equals 3x plus 2. It just means the two different ways to write the same thing. So let's look at an example. We have f of x, and what is f of x? F is the name of the function, and x is your input. And a lot of times with a word problem, you won't just use f, g, or h. You'll actually use variables that go with what relates to the equation. So for g of t, g is our name, and t is our input. And t, a lot of times, is used to represent time. Okay, so let's practice just simplifying. If we have f of x equals negative x minus 5, find f of 2. So what f of 2 means, it's just meaning plug in 2 for x. So I would write a negative, and then instead of an x, I'm going to plug in 2. So it's going to be negative 2 minus 5, and then just simplify that. That's negative 7. So we do the same thing for negative 1. Same thing, f of negative 1 says plug in negative 1 for x, and be careful with your signs, it's a negative, negative 1, minus 5. Let's simplify that double negative to be positive, and 1 minus 5 is negative 4. For f of z, this is saying plug in z for x, so it's negative z minus 5, and then you can't simplify that anymore, so that's your answer. Okay, let's look at another example. A patient's weekly dosage of 500 milligrams of a medication is reduced by 50 milligrams a week. Express in function notation the relationship between the patient's weekly dosage, d of x, and the number of weeks x. So we're told what variables to use here for the function. We're going to use d for dosage and x as our input. So the equation would be d of x equals, we started with 500 milligrams, and then it's being reduced 50 milligrams per week, so it'd be 50 times the number of weeks. So that is our function. B says find d of 2 and interpret its meaning. So d of 2 just means plug in 2 for x and simplify. and this would be 500 minus 100, which is 400. And interpreters meaning it, what this means is that 2 stands for the number of weeks, so, and 400 is your dosage. So we had a dose of 400 milligrams in week 2. Okay, we're going to talk about domain and range. Domain is your set of all first coordinates. So this was the input. So a lot of times, we use the variable x or t for that input. But what first coordinates do you have? So for this, we're going to start with a table, and we're going to highlight our domain. Okay. And so I would highlight 4, 6, and 8. This is my domain, just the first coordinates. Okay, so now let's look at this graph. Whoops, go back. 1 second. Okay, let's look at this graph. And I want to identify the domain. So the way that I look for a domain here, first you can kind of see, does this graph stop anywhere? And you actually see that it's going on and on to the left and on to the right. So I don't see any gaps or stops in this graph. And then when I'm finding domain, I'm going to look at my x-axis here. I'm looking for my input. So I start at negative infinity on the x-axis, and I read this across to infinity. And I'm seeing, are there any values I see not used in this case? And all the negative x values are used, all the positive x values are used. There's no stops in this graph. So my domain is actually all real numbers or negative infinity to infinity. You can write it either way. Now when we look at range, range is actually the set of all second coordinates. And this is our output. So an example before, that was our cost for our gas. Okay. So for this range, I want to highlight my range or my output, and in this table, it would be my y values, 0, 2, and 3. Now I'm going to look at the graph below, and we're going to do this same thing. We're going to look at the graph and determine the range. And so when I'm determining range, I'm looking at my y-axis. And I do this similar thing as we did with the domain. I start with the negative y values, which would be down here. And I read the graph up to infinity. So I start from negative infinity, infinity. I'm seeing what y values are used. And you see that this graph does stop on the y-axis. So if I go up, I don't have a y value until right here at 0. And then the y values increase and don't stop. So this domain would be y is greater than or equal to 0. There are no negative y values in this graph used, so I don't have any points down here. You can write it as y is greater than or equal to 0, or if you wanted to write it in interval notation, you would do a bracket 0 to infinity, parentheses. So either one of those would be fine. Okay, so let's get to the next slide. So there's a special test, it's called the vertical line test, to show whether a graph is a function or not. So I'm just going to draw a couple of graphs. Draw a parabola, straight line, and a circle. And the vertical line test says if you draw a vertical line through your graph and it only hits once, it's a function. So, for example, I take this parabola, I draw a vertical line. Actually use the line function. Hold on, I want to change the color of that. Let's do black. So I draw a vertical line, and if it only hits once, which in this case it does, this is a function. Okay, so let's do the same thing. Let's draw a line here. It only hits once, so again, this is a function. And then for the circle, if I draw a vertical line, it doesn't matter where you put it, and you shouldn't try and not hit twice. If you can hit twice, then that automatically tells you it's not a function. So when I draw a vertical line, it hits twice, which means my x value is repeat. If this is x is 1, this is also x is 1. So this is not a function. Okay, so we're going to look at types of functions, and we're going to start with a linear function. And this is from chapter 3 if you took 091, and a linear function, instead of y, I'm going to write it as f of x. The slope-intercept formula for linear function was f of x equals mx plus b. And just remember the slope was m, the y-intercept was b. And so let's just do an example. For some of these, all we will be able to do is write an example. But we do have a generic formula for linear function, and then I'm going to graph f of x equals 4x minus 1. Okay, so I'm going to go ahead and graph this on this calculator I have. Clear the screen. And if I do 4x minus 1 and hit graph, you can see we have a straight line. I said the -1 was the y-intercept and the slope was 4, which means from there you went up 4 over 1. Okay, but it went ahead and graphed this for me. So let's draw this. A rough sketch of this. So we had f of x equals 4x minus 1. Whoops, it's not a straight line. Hold on a second. Okay, so I'm just going to try and get, let me pick a color for this. Let's do blue. So -1. I'm just going to try and get a rough idea of what this looks like. It's not going to be perfect, but that's what we just saw on the other page. Okay, because now I want to talk about what the domain and range are. So let's start with the domain. For the domain, remember we're going to look at the x-axis right now. And I'm going to go from -infinity to infinity. And I'm looking across, is there anywhere where this graph stops or has gaps? You can see that every x value is used. This graph goes on and on. Every negative x value is used. Over here, every positive x value is used. This graph doesn't stop. So my domain is -infinity to infinity. Now for range, I'm going to look, at this case, at my y-axis. And remember, we're going to do the same thing. We're going to start at -infinity on the y and go up to infinity. And I look and I see, is there any gaps in this graph? And no, every y value that's negative and positive is used. Again, there's nowhere where this graph stops. So my range is also -infinity to infinity. And this is true for any linear function. Your domain and range is all real numbers unless you're restricting it. Let's say this is a real world problem and I'm looking at producing certain number of units. Usually then you're only in the first quadrant. You're only dealing with positive answers. So I don't say I'm going to produce -5 units of something, right? But for what we're going to be doing right now, the basics, it's all real numbers. Okay, now a constant function would be, let's change this color, f of x equals c. So some number, c stands for some number. And an example of this is f of x equals 3. This is just like when we graphed y equals 3, chapter 3. These are horizontal lines, and these are functions. Okay, and it's a good reminder that a horizontal line, first let's graph this, and I'll show you something else. So let's graph this. Y equals 3. So I'm going to erase that, and I'll put that back up in a minute. Okay, so when we graph this, we get a horizontal line going through y value of 3. So every y value is 3. And you can tell this is a function because if I did the vertical line test, it only hits once, right? So this is a function. So let's go ahead and draw this on here. So I'm going to do f of x equals 3 or y equals 3. And then I'm going to go ahead and graph this at 3. I'm just going to show that that's at 3. So here's 1, 2, 3. Okay, just label it a little bit. Okay, so now let's talk about the domain and range. Let's start with domain. I'm going to go from -infinity to infinity, and you can see that there's no stops in this graph. I have all the negative x values used and all the positive x values used. So this domain is -infinity to infinity. Now for the range, when I go from -infinity to infinity on the y-axis, you notice that there's only one y value used ever, and it's always at 3. So here, my y values are just 3. So y equals 3, or it's just, your book actually doesn't use set notation, so we'll just say y is 3. What I wanted to point out earlier is we're doing a horizontal line here. You can't do a vertical line. And we can draw a vertical line, but let's just say I draw x equals 1. Okay, this is my vertical line. Notice if I did the the vertical line test, it would hit at every single point, which means a vertical line is not a function. So that's why we're not including it with these linear examples. All right, a polynomial function. A polynomial means our exponent is positive and we don't have a fractional exponent. We don't have a variable in the denominator. And so I'm just going to do an example of a polynomial. And this would be f of x equals x squared. And we'll be dealing with these graphs in chapter 10. All we'll be dealing with is x squared or parabolas. But let's go ahead and graph this. So if I plug in x squared, okay, we get a parabola. It goes to the point 0, 0, and it's actually a mirror image on either side. So let's go ahead and draw this. So this was f of x. This was just an example of one type of polynomial, right? We're going to go ahead and Draw our lines. And then I'm gonna just do the kind of a rough sketch of this parabola. It's supposed to be a mirror image of each other. That's not right. Hold on. Okay, so here's our parabola. And again, let's look at our domain and range. For our domain, negative infinity to infinity, I go across and I don't see any places where this graph stops. All these negative x values are used. I can see that I have a value for all these, and all these positive x values are used. So this domain is all real numbers. Oops. Okay, for the range, I'm going to pick a color here. Start at negative infinity and go to infinity. And you notice as I go up, I don't have any y values here. There's nothing being used here. The first y value I have is at 0, and then all of these positive y values are used. So the range is y is greater than or equal to 0. Or remember, you can write that in interval notation, bracket 0 to infinity. It doesn't matter. Okay, for a rational function, this is what we just studied in chapter 7. But now we're going to actually graph a rational. And we're going to graph the most basic rational function. So you saw many different types of rationals. So we're going to graph just f of x equals 1 over x. Okay, so when I go to graph 1 over x, this is the graph we get. And this graph is actually showing this asymptote right here. Not all of the calculators will show this straight line here, and I'm actually going to draw it on the other page without it. And then I want to point out a couple of things with this graph. So we're graphing 1 over x. Okay, so it looked like this. All right, so notice when we have irrational functions, one of the things we talked about is the denominator cannot equal 0, because that means it would then be undefined. 1 divided by 0 is 0. So notice that at here, x is 0. There's no value used because that would be undefined. It's not possible to be graphed. So we're getting to see it visually, not just writing it down on paper right now. So for the domain, let's go across negative infinity to infinity. And you can see that all these negative x values are used, all these positive x values are used, right? The one value that's not used, and we just said this was at 0, right? There's no x value at 0 because it's not possible to graph an undefined number. So the domain is all real numbers except x equals 0. All right, for the range, if you go across, you can see at negative infinity that all of these negative y values are used. To positive infinity, all of those positive y values are used. But again, when you get to 0, this graph never crosses the x-axis, so there's no time when it ever crosses at y equals 0. So this means the range is all real numbers except y equals 0. Okay, and for the absolute value function, we're going to graph just absolute value of x. So let's go ahead and graph this one. And so to graph absolute value, you actually have to hit the math button on your calculator. You hit y equals and then the math button, and you'll see an ABS, which stands for absolute value. And then you can type in the x. And on this one I need to, on yours you probably don't need to close your parentheses, but on this one I do. Okay, so there's our absolute value. Notice instead of the U shape like the quadratic was, this is a V shape. So let's go ahead and draw this. Okay, so we're going to have two straight lines through here. V shape. All right, there's our absolute value. Okay, so then our domain and range. This is actually very similar to the quadratic we did earlier. If you go across from infinity to infinity on the x-axis, every x value is used. So the domain is all real numbers. And then for the range, when you go across from negative infinity to infinity, you can see that you don't have any y values used until you get to 0, and then all these positive y values are used. So your range is y is greater than or equal to 0.